Bismillahirrahmanirrahim. Assalamu alaikum, dear student. Today we will discuss another theory of chemical bonding that is molecular orbital theory. So in today's lecture, we will discuss that what is the molecular orbital theory, discuss the key characteristic properties of molecular orbital theory, and how the molecular orbital theory explain the bond strength of a molecule by calculating the bond order of various molecules. So first of all, let's see what is molecular orbital theory. Molecular orbital theory describes chemical bonding by combining atomic orbitals into new molecular orbitals that belong to the entire molecule. So the molecular orbital theory, in this theory, different types of atomic orbital overlap to form a new molecular orbital to be stabilized and that overlapping uh, belong to the entire molecule. It explains electronic distribution and properties like magnetism and bond strength. In the last lecture, we discussed the valence bond theory that they do not explain the magnetic properties of various molecules. So these molecular orbital also explain the magnetism and the bond order or the bond strength of a molecule. Unlike valence bond theory, which focuses on the localized bond that was sigma bond and pi bond. The electron fill these molecular orbital. There are different types of molecular orbitals when the atomic orbital combine. If constructive overlap occur, then the bonding molecular orbital will form, and if the destructive interference occur, then the anti-bonding molecular orbitals are formed. And if they are not overlap, then the orbitals are known as the non-bonding orbitals. So electron fill in these molecular orbital, which are bonding molecular orbital, anti-bonding and non-bonding, from lowest energy to the highest energy, based on the above principle, Pauli exclusion principle, and Hunt rules, which we discuss in the start lectures of this subject. These electron in the molecular orbitals, which are bonding, anti-bonding, and non-bonding, fill the electron on the basis of these different types of rules, with bonding or orbital stabilizing the molecule and anti-bonding ones destabilize it, determining bond order and stability of a given molecule. Now, let's see that how the atomic orbital combine to produce different types of molecular orbitals. We can see here the example of hydrogen molecule, that hydrogen have one electron, so its electronic configuration is 1s1. So in the atomic orbital, we can see that when the in the middle, we can see the non-bonding atomic orbital. When it combine, it form two different types of molecular orbital. One is known as the bonding molecular orbital, and in right side in the structure, we can see that when the two hydrogen atom constructively overlap, it form bonding molecular orbital, but when it destructively overlap, that the cup and thrust are opposite to each other, then it is destructive interference, and in this case, the anti-bonding molecular orbital is formed. The bonding molecular orbital have lower energy, while the anti-bonding molecular orbital have higher energy. So the electrons come in the lower energy first in the bonding molecular orbital. If there are some remaining electrons, then it will go to the higher energy level based on the above principle, Pauli exclusion principle, and Hund's rule. So according to molecular orbital theory, when the atomic orbital overlap, constructively it forms the bonding molecular orbital, and destructively it forms the anti-bonding molecular orbital. Um, the key characteristic of molecular orbital theory is that the first one is that in this molecular orbital theory, there must be molecular orbital formation. When atomic orbitals overlap, combine with each other, they form molecular orbital. The second characteristic property is that the bonding orbital which are formed may be sigma bond or phi bond, and this bond will be formed by the constructive overlap, and in constructive overlap, the electron density increases between the nuclei, lowering its energy and stabilizing the bond. The antibonding orbital will also be formed, and that antibonding orbital may be sigma antibonding orbital or pi anti-bonding orbital, and they are formed by the destructive overlap, creating a node, no electron density between nuclei, increasing energy, destabilize the molecule. So we can see that in molecular orbital theory, there are two types of molecular orbital formation. The bonding orbitals which have lower in energy and the anti-bonding orbital which have higher in energy, and they are generally represented by sigma star and pi star, and as they have more energy or increased energy, therefore these molecules are generally destabilized. Some other characteristic properties of molecular orbital is the filling of electron in the molecular orbital. When the atomic orbital overlap, they form molecular orbitals, and electron fill molecular orbital from lowest to highest energy based on the above principle, Hund's rule, and Pauli exclusion principle. Just like atomic orbital obeying the Hund's rule will degenerate orbital singly first, in Pauli exclusion principle, maximum 2 electron per orbital with opposite spin. So, on the basis of these rules, the various orbitals are filled from lower energy to higher energy. How we can calculate the bond order on the basis of molecular orbital theory? We can calculate the bond order that the molecule have a single bond, double bond, or triple bond. We can calculate it by formula that the bond order can be calculated by considering this formula, that half numbers of bonding electron minus numbers of anti-bonding electron. A higher bond order means a stronger or more stable bond. For example, we can see here the hydrogen molecule. Let's see how we can calculate the bond order of this hydrogen molecule. Bond order is equal to uh, um, half, and in the parenthesis we can see that we mentioned the 2 is the numbers of electron in the bonding molecular orbital, minus we can see the anti-bonding molecular orbital which do not contain any electrons, so it's 0. So 2 minus 0 is equal to 2, and as we consider the half of 2, so the two cancel with each other, and we can obtain the bond order of hydrogen 1. So it's mean that hydrogen can form only single covalent bond. Here is another example of molecule, the helium molecule. In helium molecule, we can see that the 2 electrons is accommodated in the bonding molecular orbital, while 2 electrons are accommodated in the anti-bonding molecular orbital, because helium have two electron in its valence shell. So we can see that the 2 electron goes to the bonding molecular orbitals, and 2 electrons goes to the anti-bonding molecular orbitals. So 2 minus 2 is equal to 0, and half of 0 is equal to 0. So it's mean that helium is a noble gas and it do not form any bond or equivalent bond. So from molecular orbital theory, we can calculate the bond order of various molecules. Now we can see over here the bond order of oxygen molecule. Oxygen have electronic configuration 1s2, 2s2, and 2p4. So only the outermost orbital take participate in the chemical bonding. So in this case, the 2s2 electron and 2p4 electron will participate to form the molecular orbital. So in this diagram, we can see that the 2s2 electron, the atomic orbital overlap to form the sigma bond, sigma molecular orbital, which is the bonding molecular orbital, and sigma star, which is the anti-bonding molecular orbital. And similarly, the p electron, we can see that the 2p4 electron overlap with each other to form sigma bond and pi bond. So in the sigma bond, we can obtain the 2 electron, the pi bond obtain the 4 electron, and the 2 electron singly occupied the anti-bonding pi star orbital. So if we want to calculate the bond order of this oxygen molecule, so it's equal to the half of bonding molecular orbital, which is 8. We can see that in when 2s orbital overlap, the bonding orbital contain 2 electron here. In the green shade, we can see in the sigma, in the sigma again, and then pi electron. So total 8 bonding molecular or electron are present. And then we see the anti-bonding molecular orbitals. So we can see that in sigma star there are 2 electrons, and in pi star there are 2 single electrons. So total numbers of electron is 4. So 8 minus 4 is 4, and half of 4 equal to 2. So it's mean that oxygen will form double bond, two covalent bond. So on the basis of molecular orbital theory, we can explain the bond strength of various types of molecule by calculating the bond order. So in today's lecture, we discuss the molecular orbital theory. That molecular orbital theory also, the valence electron is involved to overlap with each other to form molecular orbitals. And there are different types of molecular orbital: bonding molecular orbital, anti-bonding molecular orbital, and non-bonding orbital. And the bonding molecular orbital are formed by the constructive overlap of atomic orbital, while the antibonding molecular orbitals are formed by the destructive overlap of atomic orbitals. And the energy of the bonding molecular orbital is less and more stable as compared to the antibonding molecular orbital, which are destabilized, having higher energy. And from this concept, we can calculate the bond order. And from bond order, we can see that which bond is stronger and which are weaker. Thank you.